Hi, welcome to Educator.com. Today we're going to be talking about normal distributions again, but this time breaking it down into the PDF, or probability density function, and the CDF, or the cumulative distribution function. All right, so here's the roadmap for today. We're going to talk about frequency charts, which we've been doing before, and then contrast it to this new idea, but still fairly elementary, of cumulative frequency charts. Then we're going to do a very brief and broad review of calculus. It's going to be a very elementary review. No actual calculations, just conceptual. And then we're going to talk more deeply about the probability density function and the cumulative distribution function. You have to sort of reprogram yourself to see PDF and not think of it as a portable document format. All right, let's talk about frequency versus cumulative frequency. So far what we've been doing is we have some sort of variable, such as a score on the SAT verbal, and we have all these values that that variable can potentially hold. And we've been talking about what percentage of our sample or population have achieved that score. So 1% score 800, 3% score 750, right? And so that's been what we've been talking about so far. Now here, when I write percentage, I'm really talking about relative frequency. But it's largely the same thing as frequency, so not a big deal. Now when we talk about cumulative percentile, what we're really talking about is not just the people who have achieved that value, but an accumulation of everybody who has come before it. So let's start off at the bottom. So here, only 1% of the population has achieved 250 points. I think that's like one of the minimum or something. But 3% have achieved 300 or below. Right? So if you're in the third percentile, you have outperformed 3% of everybody else who's taken the test, right? Not something to write home about yet. So this 7% actually accounts for this 4% as well, plus a little bit extra. This 3% as well, plus a little bit extra. And the 16% encapsulates everybody who's come before it. Now, cumulative percentile is really helpful if you want to know your ranking in a performance. For instance, you want to know what percentile of the population you're in. You don't just want to know that 1% of everybody who's around you has also achieved that score. You want to know how many people have you outperformed. Cumulative percentile, by continuously adding all the people up that have come before you, it gives you that ranking. So when you get to, if you're in the 95th percentile, you know you've outperformed 95% of that, outperformed or equally performed 95% of that sample. And so that's why cumulative frequency is really helpful to us. But one of the things you want to notice is that cumulative frequency, when you just look at the number right away, you don't know how common that score is. So when you look at 98%, you don't know how common 750 as a score is. But you could easily find that out just by looking at the difference between 98 and whatever cumulative frequency came before it. So that difference is 3. And so 3% of people have been in that bracket. Now, another thing about cumulative frequency I want you to notice is that it's a monotonic increase. It means that there's no going up and then going down and then going back up and going back down. So there's no changes in direction. It's continuously going up and up and up and up. And that makes sense because you have to add up everybody who's come before you. All right, so that's cumulative frequency. And when you look at it on a visualization, now you could see what I mean by monotonic increase. So here we have an example of monotonic increase. This curve goes up and up and up and up because it's adding up everybody who's come before you. So you have to be at least the score before you or higher, right? And so every score is improving on the previous score. Whereas before in frequency, we could have non-monotonic curves, because here you could go up, you could go down, we could have a uniform distribution, we could have all kinds of things. But in cumulative frequency distribution, you can't have a you can have a uniform distribution. If everybody has only received the bottommost score, then you would have a uniform distribution because you'd be adding 0 every time. But otherwise, the most frequent shape that you'll see is a monotonic increase that looks like this. Here we see just this like normal-ish looking distribution, and what ends up happening when you have this normal-ish distribution, you have this sort of S-shaped curve when you transform it into cumulative frequency. Because this part in the middle, right here, sort of here, that part corresponds from about 400 to 600, right? So that part corresponds to the sort of biggest jumps. And as you see, there's big jumps here too, but the jumps are just going in one direction. All right, so that's how it looks.